Section 4.5, this is performing function operations. The two vocabulary words that you're given in this section that you're asked to define in your own words are domain and scientific notation. Of course, make sure that you've got your note-taking with vocabulary sheet in front of you before you start this video. So for domain, of course you can just think of that as all possible x values. You could think of it as all possible inputs, so either of those would be a fine way to explain domain. For scientific notation, that is just a more efficient way of working with very large or very small numbers. So just imagine that you're working with numbers like this all day long. Okay, it makes more sense to write this as 7.21 times 10 to the negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th power. Okay, same thing with really large numbers. Otherwise, you spend your whole day counting zeros, and that would be a waste of time. So that's the point of scientific notation. In the first set of problems, we're asked to find f plus g of x and f minus g of x. And before I do that, I'm just going to invite you to look at your core concept, where they explain how function operations work. It's very intuitive. If you're adding two functions together, then you just add all of the terms together. If you're subtracting two terms, then you would just subtract. It's very intuitive. There's not really anything here that I think requires further explanation. I'm just going to jump into the examples. Okay. So, in number 1, we want to find f plus g of x and f minus g of x and state the domain of each. Then evaluate f plus g and f minus g for the given value of x. So we're given f of x equals negative 1/2 times the cube root of x. G of x equals 9/2 times the cube root of x. And then after we find the sum and the difference, we have to evaluate each for x equal negative 1,000. So in this section, you definitely need a separate sheet of paper. You will not be able to squeeze all of this into your note-taking with vocabulary page. I started to, I tried, but I couldn't do it, so there's no need to try to make it all fit. Just go to a separate sheet of paper. So when I do f plus g of x, first I make sure I label what I'm getting ready to do, otherwise it's going to be hard to keep track. F plus g of x equals, so it's going to be the f function plus the g function. So negative 1/2 times the cube root of x plus the g function, 9/2 times the cube root of x. So just f of x plus g of x. What can I do with this? Do I have like terms? Well, they both have cube root x, so these are like terms. If one of them had a y on it, or if one of them had a fourth root on it, then you wouldn't be able to combine it, but these are like terms. Negative 1/2 plus 9/2 would be 8/2, which is 4. So that gives me 4 times the cube root of x. Okay, so that's the first part. I have to give the domain. Okay, so think about what you know about radicals with an odd index. So is it okay to have negatives inside a cube root? Yes, it's fine. So you don't have any restrictions on x when you have an odd index. So your domain is all real numbers. Okay, instead of writing out all real numbers, you can do this symbol. So r would basically 2 backs to it. And you can do the interval notation, parentheses, negative infinity to positive infinity. So any of these are acceptable. And then let's evaluate it for negative 1,000. So f plus g of negative 1,000, and I don't know if I can squeeze it in my little space here, but f plus g of negative 1,000 means I'm going to go here, substitute negative 1,000 for x. So 4 times the cube root of negative 1,000. 4 times the cube root of negative 1,000 is negative 10. So that gives me negative 40. Okay, so that was what I was asked to do for f plus g of x. Now I'm going to do it for f minus g of x. I'm not going to do every one of these problems. I think one example of each type is sufficient, because the rest of it is just making sure you can combine like terms and understand how to do domain. They do have quite a few steps though. But, so let's do the second part, f minus g of x. So f minus g of x, what is this? You need to do f of x minus g of x. So negative 1/2 times the cube root of x minus 9/2 times the cube root of x. Okay, they're still like terms, so you can still combine them. You want negative 1/2 minus 9/2. So that's going to give you negative 10/2, which is negative 5 times the cube root of x. The domain for this is still all real numbers, for the same reasons that we had in part A for the f plus g. So you can do all real numbers, you can do negative infinity, positive infinity, and then evaluate for negative 1,000. So f minus g of negative 1,000, put negative 1,000 into this step, negative 5 times the cube root of negative 1,000. Negative 5 times negative 10 gives me positive 50. And that's it for number 1. Let's look at number 3 together. I said I was going to do one from each section, but I actually do need to show you something. So look at number 3. I'm just going to, the addition I think is pretty self-explanatory, but I want to do the subtraction piece for number 3. So I'm going to do f minus g of x. That's f of x minus g of x, if you need that extra step. That's the idea there. So f of x for number 3 is 4x cubed plus 12. And then when I subtract g of x, notice g of x is a trinomial. It has 3 terms. So because you've got multiple terms in your second function, make sure that you put this in parentheses so that you can distribute your negative. So you're going to subtract 2x squared minus 3x cubed plus 9. Okay, so this is the only thing that's different in number 3, is that you've got to make sure you're distributing that negative through the g function. So this gives me 4x cubed plus 12 minus 2x squared plus 3x cubed minus 9. So like terms gives me 7x cubed minus 2x squared, and 12 minus 9 is 3. So that's f minus g of x. And they want us to evaluate this one when x equals 2. So we're going to do f minus g of 2. So just substituting 2 in here. Oh, and I forgot to do my domain. What is my domain for this? There are no restrictions on x. You do not have square roots. You do not have fractions that have variables in your denominator. So, and those would both be situations where you would have some restrictions on your domain. You don't have either one of these. You can put anything in here for x. You'll always get an answer back. So the domain in this one is all real numbers. Negative infinity, positive infinity. So f minus g of 2, substituting 2 in here, you're going to have 7 times 2 cubed minus 2 times 2 squared plus 3. That's 8 times 7, so 56. 4 times 2 is 8. 56 minus 8. Okay, so that gave me 31. So this turned out to be 31. I don't know if I think it'll show up on there for you, but those 31 is the answer there. Okay. Otherwise, it's just a matter of combining like terms, just adding the functions, subtracting the functions. Make sure that you remember to distribute the negative if your second function has more than one term. All right, let's look at the bottom of the page. Let's do number 5. Directions are a little bit different. Here they want us to find f times g of x and f over g of x. F times g of x, f divided by g of x. State the domain of each, then evaluate f times g and f over g for the given value of x. And number 5. Should I do 5 or 7? I don't think it makes any difference really. I don't know. Let's do number 7. So f of x equals 0.25 x to the 1/3 power. G of x equals negative 4x to the 3/2 power. We have to evaluate for x equal 1. Okay, so the rules here, if you look back at the first page of your notes, f times g of x, all that means is that it's going to be f of x times g of x. So you just multiply the two functions together. If you're given f over g of x, that just means you're going to do f of x divided by g of x. So the only thing that happens here is that the domain you have to be careful with when you're dividing, because remember you cannot have a denominator of 0. So that's the only little thing that's you got to pay special close attention to. The rest of it is still pretty intuitive. So for f times g of x, we're going to multiply. So we're going to do 0.25 x to the 1/3 power times negative 4x to the 3/2 power. Now, because you're multiplying these, be careful. If you have multiple terms, you may end up having to FOIL, or you might have several steps for multiplication, just depending on the problem you're working with. So I'm going to multiply these. 0.25 times negative 4, that's going to give me negative 1. And then x to the 1/3 times x to the 3/2. I add my exponents. 1/3 plus 3/2. And 1/3 plus 3/2, how much is that? Find the one I did before. Okay. 1/3 plus 3/2 gives me 1/6. So I've got negative x to the 1/6 power. You don't have to put your 1 there. For my domain. Okay, because this is an even denominator, that's the same thing as if you had negative 6th root of x, which that's not the domain, but that's what it means. Because it's the even root, so if you've got negative 6th root of x, do I have to restrict my domain in this based on the inside of the radical? Because this is an even index, I know I cannot have negatives inside that radical. So I have to make sure that the inside of the radical is always non-negative. So that means for this particular problem, x has to be greater than or equal to 0. Or you could say square bracket 0, comma, infinity for your domain. They also want us to evaluate at x equal 1. So to do that, so I need to find f times g of 1, I don't know why I said negative 1, f times g of 1. So that means I'm going to come here, substitute 1 in. That's negative 1 to the 1/6 power. That just means negative 6th root of 1. What is the 6th root of 1? It will be 1, because 1 times itself 6 times is 1. So that's negative 1 for that part. Okay? And then we do the same thing for the division. So f divide by g of x. That means you're going to do f of x divided by g of x. So you're going to do 0.25 x to the 1/3 power divided by negative 4x to 3/2 power. Simplify that. 0.25 divided by negative 4 gives me negative 1. No. 0.25 divided by negative 4 is actually negative 1/16. So you can keep your negative out here. Don't forget your negative. Where you had the negative in the denominator, it can sit out front if you want. So you can just say it's negative. And then 0.25 divided by negative 4 is 1/16. So you can put a 1 in the top, 16 in the bottom. And then x to the 1/3 divided by x to the 3/2. I know I need to subtract those exponents. So 1/3 minus 3/2 gives me negative 7/6. So I've got negative x to the negative 7/6 over 16. We generally do not care to have negative exponents in a problem. It's not really fully simplified if you have a negative exponent. So we'll do the reciprocal, move it into the denominator, and we've got 1 over, we've got that negative still out there. So negative 1 over 16x to the 7/6 power. So if this seems complicated for you, it's probably because you still need to practice your rules for exponents. Because there's not a lot of new material here. There's really not. It's just a matter of applying what you've already done, maybe in a slightly new way. So now we have to evaluate, we need to find f divided by g of 1. And I forgot I was supposed to do my domain there. What is the domain for this? You have to make sure that you do not have 0 in your denominator. So x cannot equal 0. Because if you do the 6th root of 0, you get 0. So you cannot have a 0 equal to x. And because this is a 6th root, you also cannot have a negative inside that radical like we saw in the first part. So x still has to be positive. So you could kind of combine this by simply saying x is greater than 0. And you could say, for integral notation, the domain is 0 to positive infinity. Okay, so this is your domain here. And now evaluate that for x equal 1. So you're going to use what you did here, is substitute 1 in. So negative 1 over 16 times 1 to the 7/6 power. And that's going to be negative 1/16.